Hi people! So we've talked about area, now we're talking about volume. Volume is being able to calculate volume to enable you to work out how much packing space you have when you're moving house, or how much office space you need, or how much jam you can fit into a jar, a range of things, but it's basically talking about capacity. And we've got a few main formulas that we use when we're talking about volume. You would have hopefully have seen some of these before. We've first got a rectangular prism, and the formula for the volume of a rectangular prism is the length times by the width times by the height. And so that's this example here. We've got our rectangular prism. So if we do a quick example of that, we've got this rectangular prism below, and it's got a length of 2.2 meters. We're going to multiply that by the width of 61 centimeters. Now the really important thing to remember here is that when you're calculating volume, you have to have the units all the same. So we've got meters and centimeters. Therefore, we just need to do a quick calculation to convert meters into centimeters into meters. 61 centimeters is actually, to convert that to meters, we're going to divide that by 100. Now you might remember that's the same as moving the decimal point two places to the left, which is 0.61 meters. You could easily do that on the calculator. So we've got 2.2 meters times by 0.61 meters times by 1.9 meters. That gives us an answer of 2.55 meters cubed. We talk about meters cubed because we've got meters times meters times meters. We've got three measurements that we're multiplying together. You might remember in area we talked about meters squared. That was because we had two measurements multiplied together. But for volume, it's always going to be a unit cubed. So rectangular prisms is one type of prism that we want to find the volume of. Another type is a cylinder. A cylinder is the shape with the circle down the bottom, and then it's like the continuation of that. It's like a water pipe. And so if you see over here, we've got the generic formula for the volume of a cylinder. It's pi r squared times by the height. So remember that the radius is half the width of a circle. If we've got a circle here and we've got a line all the way across, through the center, that's called the diameter. The radius is going to be half that. So if we're trying to calculate then the volume of a cylinder, like this example here, what we've first got to do is actually work out what the radius is. So we've got a diameter, it crosses all the way through the center of the circle from either side of the circle to each other, so the radius is going to be half the diameter. So the radius is going to be 1.8, that length, divided by 2, which is 0.9 meters. So our volume then is going to be pi r squared times by the height. Just to raise the other question, if you're taking notes, which would be a really good idea to do, put the example of how to calculate the volume of the rectangular prism into your glossary. And then we're going to substitute in the values for the volume. So the volume is going to be pi, and we just leave it like that because we can enter pi on the calculator, times by r squared, so that's 0.9 squared times by the height. And the height in this case is this length here, that's 1.4 meters. So if we put that in the calculator, we get the answer 3.56, and again, because our measurements are in meters, it's going to be meters cubed, not meters squared, meters cubed. It's a little bit messy, it's going to be meters cubed, always the unit cubed for volume. So that's the volume of a prism and the volume of a rectangular prism and the volume of a cylinder. We've got one more formula in here. That's this one here, and that's the volume of a solid with uniform cross-section. What that means is if you take a shape, and in this case we're looking at this staircase looking shape, and you cut it up into different sections, and then you looked at the ends, all the ends would still look the same. You imagine that if you see one of the ends here, if you cut this shape up, you would still always get at the end this shape. And so that tells us it's got a uniform cross-section. When we cut it in different bits, it's the same. So if we think closely about that one, just this formula here, we've the solid of a uniform cross-section, the volume of that is just going to be the area of the end times by the height. Now this works for any shape. If you think about the rectangular prism over here, and we use that formula. We use the formula that it's the area of the end times shape, times the height. And we think about, well, say the bottom bit, we call that our end. So this bottom bit down here, if we did the area of that, that would be length times width anyway, because it's the area of a rectangle, and then we times it by the height. So that works for any shape we've got. This formula always works. If you've got the area of the end of it, so the area of this bit of it, which is uniform or the same when you cut up the rest of the shape, all you have to do is multiply that area by the height. Now sometimes you won't be given the area of that, but you might be able to work out the area of that. And so we'll do an example of one of those questions. So let's have a think about this example here. As you can see, it's not exactly a rectangle. It sort of looks like a rectangle that's been squashed. And what we call this shape on the end is a parallelogram. And you've probably seen this sort of shape when you're doing area calculations. So we first go, well, does it have a uniform cross section? If you cut this shape up, would the ends all look the same? And the answer is yes, and you can probably see that. So if it's that case, so that it's not a rectangular prism or cylinder, we just use the formula that the volume is going to equal the area of the end times by the height. So we've just got to work out what the area of the end is, and if you look at your formulas for area, you'll know that the area of a parallelogram, which is what this is half times the base times the height of the parallelogram, and then we times that by the height. So just be careful with there, because we've got height mentioned a couple of times. In this case, it's talking about the height of the parallelogram here, and in this case, it's really talking about the other measurement. So it sort of looks more like a length here. If we then substitute in the values, we're going to get a half times 18, that's the base, and the height is 15, and then we can multiply that by the height of the object, or the length of the object, which is 27. And so we get a final answer of 135 centimetre cubed. Really important to check your units. In this case, the question is in centimetres, so you can give your answers in centimetres cubed. Hope that helps with some of the more simple ones, and then there'll be another video on some of the more complex ones. Enjoy.